Hi everyone, let us go back to our real numbers, chapter 3. And whoever wants to follow my channel can put a like and subscribe to the channel. I wish to put on all the sums and all the lessons on YouTube so that you can click on the link which is given in the description box. Now returning back to our exercise, we are going to come back to irrational numbers. You all had been studying irrational numbers in 9th standard. So pretty well now you would be very thorough with it. Okay, now let us come back. What is irrational number? Any number which can be written as P by Q and where Q is not equal to 0 and if the end result of this number is going to be continuous. Suppose consider some prime number. Okay. Prime number, consider prime number, square root of prime number, any prime number, square root of 2, square root of 3, square root of 5, square root of 7 and also our famous number pi. All these numbers, they keep on going, they are not ending numbers. Such numbers, what can we call it as? These numbers are called as irrational numbers. Okay, now shall we go back to the chapter? The first question is, prove that square root of 5 is irrational number. Okay, there is no such direct proof that any number is irrational number. Okay, so they have given a theory what is a rational number, and when we are not going to get proved that this number is not a rational number, we can conclude that it is an irrational number. Prove that square root of 5 is irrational. This is the question, okay. But what we are going to do? We are going to consider that square root of 5 is, square root of 5 is a rational number, okay. So when we consider this as a rational number, what we do then? First, we can write this number as in the form of P by Q. That is the first definition of being a rational number, right? So I am going to write this number in the form of P by Q or A by B. The last exercise we did it as A by B. So we will continue with that A by B. Okay, A by B. I am going to write this given number, which is a prime number, as A by B format. And what we do? We can bring this B to the numerator this side. So it becomes 5. B square root of 5 is equal to A. And squaring on both the sides, I get B 5 here, that square root has gone, so 5B square is equal to A square. Then I am writing B square is equal to A square by 5. Here we have to remember the theorem. The theorem says if any number, we are able to divide that number by 5. Okay, by any number. If I am able to divide A square by any number, I can also divide A also by the same number. It gives this end result, proper number, not an indefinite number. So because of that theorem, I can write B is equal to A square by A by 5. Now let us consider that A is equal to 5k. We are introducing a new integer. We don't know what is the end result of it. So I am going to introduce a new integer k. And now B square is equal to, in the place of A, I am going to write 5k. 5k. So it is going to be 25k square. Okay. And by 5. Okay. So now this B square is equal to, B square is equal to 5k square. When I divide, this becomes 5 here. So B square is equal to 5k square, and I can write this also, B square by 5 is equal to k square. And again what I get? B square, it is again possible to divide. Okay, when I do square root, it becomes B by square root of 5 is equal to k, right? And here also I got the same thing with A. The same number A and B is being divided by square root of 5. If these are going to be equal, then I can say that square root of 5 is a factor of A and also for B. But it's not possible. So, because of contradiction theorem, we can say square root of 5 is irrational. 5 is irrational. It doesn't go only with square root of 5. This theory is applicable for any prime number. The first thing is, I will repeat it again. First thing is, we are going to consider the square root of 5, square root of any prime number as a rational number, and I am going to write it in the form of a rational number a by b, and I am going to square it on both the sides, and after squaring I leave it here. I consider this a is equal to 5k, a new integer I am introducing as k, and again I am squaring it on both the sides. I find the value of k, which is equal to a by square root of 5, b by square root of 5. Here both the square root of 5, it's the denominator, which also means that they are factors of this a and b. But being a prime number, it cannot be a factor of this prime numbers. So for a and b, and so because of that reason, square root of 5 becomes irrational. Because of contradict theorem, it becomes irrational. The second sum is, we have to prove that 3 plus 2 square root of 5 is irrational. Okay. And again we have the same square root of 5, the prime number inside the square root. Okay. With this, remembering that, we are going to continue this sum. We are going to consider the whole number. Let this whole number 3 plus 2 square root of 5 be a rational number. We are going to consider it first. Okay. Again we are going to prove with the same contradiction theorem only. So I am going to consider 3 plus square root of 5 be a rational number. And when I consider it as a rational number, I can write it as a by b. Now I will leave this number alone here. I take this 3 the other side, minus 3 plus 3 comes here as minus 3. And when I square it on both sides, a and b are integers, right? And they are rational also. This a and b are integers, and we know it's a rational number. The best example of rational number is a by b, and so we know a and b are, a comma b are integers and are rational, and because of that we can say that this square root of 5, we know already it is an irrational number, but this a by b is a rational number. You cannot give an answer for a irrational number. So again, as per contradiction theory, we can say that this square root, this whole expression is irrational. By contradiction theory, this 3 plus 2 square root of 5 becomes irrational. The very first question only has got the answer. We are just using the answer which we have got from the first question. Okay, we will go back to the third sum now. 1 by square root of 2. Again we are going to use the same logic. I am going to consider this number to be rational. Let 1 by square root of 2 be rational. Then 1 by square root of 2 is equal to a by b. When I consider it rational, automatically I can equalize to be a by b. Okay. And when I square it on both the sides, I can write it as square root of 2a is equal to b. And I can write it as square root of 2 is equal to b by a. And a and b are integers, and so this gives a rational, this becomes a rational number. This number is a rational number. But again, we know that already square root of 2 is an irrational number, because 2 is a prime number. Any square root of prime number is an irrational number. So this is not possible. By contradiction theory, we can say that even 1 by 2 also is not a rational number. It becomes irrational. So by contradiction theory, So you have to understand we are using only one logic. First we have to consider it as a rational number and then prove that this is not possible because it is a prime number which is under square root. So it is not possible, and because of that it comes under contradiction theory. By contradiction theory, square root of 2 is not rational. So 1 by square root of 2 is irrational. Okay. Every sum we are going to follow the same logic. 7 square root of 5. We have to prove that this number is again irrational. But as usual, let us consider 7 square root of 5 to be rational. Okay. And when we consider it rational, we can automatically equate it to be equal to A by B. And when I equate it, what happens? This B comes here. This 7 I can. I will leave square root of 5 alone on the left hand side and bring 7 to the right hand side. Again, I have 7 is an integer, A and B are proper integers, and so this is a rational number. This A by 7B is a rational expression. Okay. So when this becomes a rational expression, this square root of 5 also becomes rational when we are equating it. But square root of 5 is not a rational number. We know that. We have proved it already. And because of that, we are saying that by theory of contradiction, this number 7 square root of 5 becomes irrational. Okay. So by now we have done some 5 sums. You would have been knowing the logic now. Okay. First we are considering the number to be rational and proving that the end result of the number is rational number. So it cannot be rational. So because of that reason, we are calling it irrational. Again, let us consider 6 plus square root of 2 to be rational. Okay. When I consider that, automatically I equate it to be equal to A by B. And I bring the 6 to the right hand side. I leave only the square root of 2 this side. I bring the 6 to the right hand side. It becomes minus 6. Again, this whole thing, it is a rational number. And because of that reason, we know already that square root of any prime number is irrational. Square root of 2 cannot be a rational number. With that logic, we are by contradiction theory, we can say 6 plus square root of 2 is irrational. Okay. I think now everyone would be knowing how we are proving a number to be irrational.